Hello guys, in this video we are going to see about flip-flops. SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. First we'll see SR flip-flop. This circuit is used to store the single data bit in the memory circuit. So the SR flip-flop has a total of 3 inputs, that is S and R and current output Q. This output Q is related to the current history or state. The term flip-flop relates to the actual operation of the device, as it can be flipped to a logical state or flopped back to the opposing logic reset state. The set state, the input R is set to false or 0 and the input S is set to true or 1. The NAND gate Y has an input 0 which will produce the output Q dash. The reset state, R is equal to 1 and S equal to 0. One of the inputs of NAND gate X is 0 and its output Q is 1. Next we'll move on to characteristic table and clock pulse. First clock pulse, second, third, fourth, fifth, sixth, and we'll get the output at the 8 clock pulses. And then now we will go into JK flip-flop. JK flip-flop is basically a gated SR flip-flop with the addition of clock input circuitry that prevents the invalid output condition that can occur when both inputs S and R are equal to logic level 1. Due to this additional clocked input, a JK flip-flop has 4 possible input combinations: logic 1, logic 0, no change and toggle. We'll see the characteristic table. Same as for SR latch, will be same, and toggle action is the only difference. And you can see memory no change, where it will come at the reset state and then set state at last at the toggle state. Next we'll see D flip-flop. In this flip-flop we can see D flip-flop are constructed from a gated SR flip-flop with an inverter added between S and R inputs to allow for a single D input. Then the single data input labeled D and is used in the place of the set signal, and the inverter is used to generate the complementary reset input, thereby making a level sensitive D type flip-flop from a level sensitive SR latch, as now S equal to D and R not equal to D as shown. It will store and output whatever logic level is applied to its data terminal, so long as the clock input is high. Once the clock input goes low, the set and reset inputs of the flip-flop are both held at logic level 1. We'll see the characteristic table. In this we'll get only 4 characteristics table: 0, 0 state. If the input is 1, output will be 1, and input 0, output will be 1 when the clock pulse is 1, and the clock pulse is 1. And if the input is 1, the output will be 0. In T flip-flop is a simplified version of JK flip-flop. It is obtained by connecting the same input T to both inputs of JK flip-flop. It operates with only positive clock transitions or negative clock transitions. Here the inputs of JK flip-flop are considered as J equal to T and K equal to T. In order to utilize the modified JK flip-flops for 2 combination of inputs, we have Q of T and Q of T plus 1 of present state and next state respectively. So T flip-flop can be used for one of these 2 functions, such as hold and complement of present state based on the input condition when positive transition of clock signal is applied. Let us see the characteristic table. Same 0, 0, 1, 1. When you will give 0 input, 0 will be the output, 1 input, 1 will be the output at pulses 1, let us experiment these flip flops in the simulation lab.
And this is the website logic.ly. In this, we are going to simulate the flip flops. First, we'll take with the SR flip flop. Before that, we need two inputs as toggle switch A and B. Just take not A and B. For SR flip flop, it will be SR and clock pulse. So now I'm taking this off flip flop. I'm just giving connections. One for S and R, and then clock for signal pulse, and two bulbs for getting the output. One for Q and one for Q dash. That is next state Q dash and Q previous state. When 0 0, the Q dash remains the previous state as 0. Now Q S is 1 and R is 0, it goes to the set state. When S is 0, R is 1, it goes to the reset state. When both are 1, there is no state over here. It will keep on changing. It will go to the invalid state. That's it. Now next we'll go on to with the modification of SR flip flop, JK flip flop. In JK flip flop, the invalid state is the inverse. Invalid state is modified into the inverse of the previous state. I forgot to give I constant and push button. Let us take for not get over there. I'm just searching for not get, and then giving connections. When both are 0, it is already in the previous state. Now if we give J as 0 and K as 1, it remains in the set state. When J as 1, K as 0, it is in the reset state. If both are 1, it remains in the inverse of the previous state. It will be in 1 or 0. It will keep on changing. The previous state is 1, it will be 0. If previous state is 0, it will become 1. This is how JK flip flop works. Now let us move on to D flip flop. D flip flop. Just give the connections. In this we will give only one input, so that for this I have to give an AND gate. The AND gate operation of another input will be given, so that it will work. And in Q is the previous state, Q dash is the next state. If both are 0, it remains in the previous state. 0 1, it will be the same, and 1 0, same. 1 1, it will be in any of the states as well. Now let us move on to T flip flop, in which both the inputs will be same. No change in the inputs, just the output, and no change in the outputs. What is the difference between D flip flop and T flip flop is, in D flip flop the another input is given as the inverse of the first input. That's here we'll give both the input as same. First I'm giving 0 and 0. It will be 0 and 1. If 1 0, 0 and 1. If 0 and 1, 0 and 1. If both are 1, we'll see the change. Yeah, we'll see the change over there accordingly. This is the experiments done in the stimulation lab for flip-flop. Thank you guys for watching this video.